Okay, so good morning. Good morning, everyone. Today we will have our webinar for SPM Chemistry. So before that, I want to ask, is it my voice clear enough? If yes, can you type on the chat room so I will know? All right, thank you. Okay. So again, good morning and welcome. So today, for this morning, we will have SPM Chemistry, Chapter 3, Mole and Chemical Formulae, Paper 1. Okay, so my name is Anis. I think some of you may recognize me. Okay, so today, our presenter, which is our lecturer, Ms. Leong Shiki, she will be in charge for today's chemistry paper. So before we start, just as usual, a reminder for everyone. So if you have any question along the webinar, you boleh tanya dekat chat. So you boleh type from time to time, and after that, we will answer it during the Q&A session. Okay, and then let's say you want to use your voice, you boleh use the raise hand button in your chat room, and then I will give you the time for you to talk if you want. Okay. And then for Q&A, we will open at the 10 last minute. So maybe around 5 or 10 minutes before we end, I will open for Q&A session. And then remember, please off your webcam and your mic so we don't want any interruption during the webinar. And then for the e-cert, we will give for those yang join the live only. Let's say ada your friend yang he or she register, but then she didn't go live during this time, so we will not give the cert. Only for those yang come during live saja, they get the e-cert. Okay, and then before we end, we open the link for you to fill in. Okay, and then remember, this webinar will be locked down after 15 minutes, so maybe around 10:15 we will lock down the webinar. So kalau you leave the this webinar, nanti you tak boleh join. So make sure you jangan leave. And then if you have your friend yang belum join, please ask them to do now, because after this we will lock down. So nobody we can get in. Okay, remember that. And then for today, what we learn is pengenalan tentang mole. I think maybe some of you, or I think now is chemistry in BM if I'm not mistaken. So we learn something about mole, and then teknik jawab soalan mengenai mole, and then pengenalan tentang chemical formula, teknik jawab soalan mengenai chemical formula. And then at the end of this webinar, you akan tahu mengetahui penggunaan mole dalam kiraan tentang atoms, molecule, ions, mass and gas. Okay, dan mengetahui langkah-langkah dalam pengiraan empirical formula dan molecular formula. Okay, so today is chemistry. Okay, I dulu chemistry pun quite tough for me. So I hope today you boleh guna sebaik mungkin untuk mengenai mole. I think mole ni kalau you tak master about mole, and then your chemistry nanti susah, if I'm not mistaken lah. So this one is very important topic before you go further for your chemistry. Okay, this one is form 4 topic. So kalau for those yang form 4, maybe you can yang belum belajar ataupun yang dah belajar, you boleh revise balik. And then yang form 5, very important for you untuk revise balik. So this one the very basic one for chemistry. Kalau you tak master this one, nanti susah. Okay, so make sure you use the time for this webinar, learn as much as you can. Okay, if you have question, you boleh tanya. So I nak introduce our speaker today is our Ms. Leong Shiki. She is our chemistry lecturer at Segi College Penang. And then she graduated from Bachelor in Applied Science, Industrial Chemistry, University Science Malaysia. And then she have a very strong academic and teaching experience, 7 years in chemistry subject. And also, she is a registered chemist under Institute of Chemistry. So, she is a very talented person. So, I'm sure you will use this time wisely. Kalau ada soalan, tanya. Jangan malu. Okay? So, without further ado, I will pass the mic to Miss Liang to continue for our webinar today. Okay, Miss Liang?
Yeah, okay. Thank you, Hanis. Okay. So, good morning. Good morning, everyone. So, I just want to confirm whether my mic sound is clear to everyone or not. Yeah, if yes, then you may type in the chat room and then let me know. Okay, good. Okay. So now I will go into, so for today class, okay, so we're going to discuss about the concept that we call as a mole. Okay, so just to cross-check, can you all see the slide that I share now? If yes, then you all just type in the chat room and then let me know about it. Yeah, okay. So we will start our class now. Okay, our webinar. So basically for today class, I will combine like English and Malay lah. Okay, so if you're having any difficulty, then you may type in the chat room and then you may let me know. Okay, so first of all, as we have mentioned by Hanis just now, so mole concept is a very, very important topic. So basically in mole concept, if you are in Form 4, you have covered before. Okay, I believe in chapter 3. So most of the students, they are very, afraid on this topic. Okay, so today I will try my best, okay, to help you all to learn how we're going to solve this topic with a few techniques. Okay, so without further delay, we will go into this topic. So if you can see for this concept map here, so basically when we discuss about mole, we can actually link them into these four main category. Okay, so the very first category that we have here, okay, the very first category we have here, we can link to number of particle. Okay, so if you still remember, when we link mole to number of particle, basically you will come across on this number. So this number, we call this as Avogadro constant, or usually we call as Na. Okay, so when we talk about number of particle, if you still recall, we have three type of number of particle. The first one we call as atom. So the second one we call as molecules. And then the third one we call as ions. So when we mention anything on particles, we can separate into these three terms. So what is the difference between atom, molecule, and ion is that? So I give you one simple example. Anything on atom will be only O. So O will be for oxygen. Okay, so if you only see O alone without any subscript, okay, so we call it as an atom. So when we call it as a molecule, so you will see as O2 as a subscript. So molecule will be O2. In O2, basically, you also consist of two atoms of O. Okay, and the third one, we have ions. So if oxygen become ion, it will form O2 minus. So when you see the charges as positive, negative, then you will know that these will be ions. Okay, so I give you another example. Okay, so if I'm having a compound, okay, an ionic compound with this chemical formula, Na2O. So with this Na2O itself, we can actually know that this is a ionic compound. So how do I know this is an ionic compound? Because we have metal and then we have this non-metal. So when you have metal, non-metal, we can say that this is an ionic compound. So they should consist of ion. So in this compound here, we can say that total there will be 3 ions that is present, where it consists of 2 Na positive, 2 sodium ion, and 1 O2 minus. So from here, we know that this is having 3 ions. So when we calculate number of particle, we need to times 3 if the question is asking on ion. Okay, if the question is asking number of molecule. So if they given you the formula is O2, then O2 is considered as one molecule, then you just need to times 1. Okay, so atom is very clear cut. So whenever you're going to count how many atom or how many element, so if you only see one O, so you just times 1. So if you see 2O, then you need to times 2. Okay, so this will be the important thing that you need to take note in number of particle. Okay, so secondly, we will be moving on to this gas section. Okay, so before I moving on into this gas section, so I have a question here. Okay, so my question is, what is the volume of gas at STP condition? Okay, so will you all able to type into the chat room, and then you all may let me know about this? So you will just need to type what is the value of the volume at STP. Okay, so I can see some of your answer. Some of you type 22.4, some of you type 24. Okay, so let's see what is the answer for this, huh? Okay. So the answer will be 22.4. Okay, so you got it correctly. So if yes, you may give yourself a clap. Okay, so this is an important thing. Okay, so volume of gas at STP condition. So STP we call as standard temperature and pressure. Okay, so anything in standard temperature and pressure, if you still recall, we are mentioning on 0 degrees Celsius and 1 atm. So at this condition, the volume will be as 22.4. And we will show in unit dm cube. Dm cube is called decimeter cube. Okay, where always 1 decimeter cube will be equivalent to 1 liter. Okay, so the volume as RTP condition, so it will be equivalent as 24. Okay, RTP is where we mention as room temperature and pressure. So anything room temperature and pressure, we can saying as 25 degrees Celsius and 1 atm. Okay, and just for your information, most of the time, the unit in the SPM question, usually they will be given in cm cube. So I will just let you all know the conversion between 1 dm cube into 1 cm cube is equivalent to 1000 cm cube. Okay, so most of the time you might need to do the conversion from cm cube to dm cube. Okay, so far we have done for the gas part. Okay, so the following part, we can link more to the mass. So mass, usually you will link to those solid. Okay, so anything we can measure in terms of gram, so we can call it as a mass. So mole can link to mass by times with molar mass. Okay, so molar mass is a very general term where we can also classify our molar mass into few important category. Okay, so the very first category that we can have in molar mass is that we can categorize into this term we call as RAM. So A is called as atom. So RAM is what we call as a relative atomic mass. And then second one, you might heard it before, we call RMM. And then the third one, where we quite seldom use it, we call as RFM. Okay, so RAM is the information you can get from your chemistry periodic table, okay, or your data booklet. So usually, how do you differentiate RAM with proton number? So I give you one example. So if in periodic table, if I have carbon, I have usually you will see two numbers. Okay, so whichever the larger the number or the bigger number, usually we are referring to RAM. So the smallest number usually are referring to proton number. Okay, so RAM is something you can get from periodic table. So RMM is something that we call as the total or the sum of RAM. Okay, so for example, if I have O2 as a molecule, so what I need to do is that in order to calculate the RMM, I will just need to get 2 times 16. So this is how I get as 32 as my RMM. Okay, so the following one, RFM. So RFM, usually we are referring to ionic compound. Okay, so I give you the same example. So if I'm having Na2O, so if I going to calculate what is the RFM for this, also the same thing, we just need to total or sum up of RAM. Okay, so if you check from your periodic table, if you have your periodic table with you, so you will be able to know that sodium is basically having a RAM of 23. So I get 23 times 2. Okay, then I total up with 16. So from here, I will be able to get a value of 62. Okay, so molar mass is actually a general term that comprises of RAM, RMM, and RFM. So one thing to remember is that whenever we mention anything on RAM, RMM, RFM, usually no unit. But when we mention on molar mass, then we will give a unit gram per mole. Okay, so hope that you all can have a clearer picture on how we link mole to number of particle, to volume of gas, and to mass. Okay, so without any further, okay, I will show you all on another more simplified slide. Okay, so if you are a person that you like to remember in terms of picture, okay, if you are not a formula based person, then I will suggest you that you may remember as this diagram, okay, where you remember all these three, the mole concept in terms of formula in this three triangle. Okay, so in this three triangle is actually linked mole together. So you can see in this triangle there will be one similarity. You having n, n, and n in each of these triangle. And this n is where we usually use n to represent on mole. Okay, so normally in the SPM question itself, it won't only test you in one category. For example, usually they will link, for example, two of these triangle together. So meaning to say that they may be giving you number of particle. So they want to ask you what will be the mass, okay, that you can calculate out. So that is how you're going to link the two triangle together. Okay, so in this three triangle itself, okay, what I will do is that I will put in this right hand side part as a constant value. Okay, so you can see from here 6.02 times 10 power 23. So this is the Avogadro constant. So this is something you can get from your periodic, your data booklet or your periodic table. So it's a constant value. So same thing in the second triangle on the mass itself. Also, I put it as a molar mass here, meaning to say that all this information you can get from your data booklet, your RAM. Okay, and then for the third triangle also, you can also get this value, volume of gas, 22.4 or 24, also from your data booklet. So whenever you're going to remember on this triangle, always remember whichever thing on the right hand side will be those things you can get from data booklet, where it will be a constant value. Okay, and the left hand side will be everything on the mole. So this is how you link them together. Okay, so instead of remember on this triangle, so I will just write the formula here. So if you are a formula based person, then you may just remember the formula every time you put the number of mole on your left hand side. Okay, so the reason is that it will be much more easy for you to link to find the relationship in the question. Okay, because most of the time they can link together by mole. Okay, so if you're going to link by formula in the first triangle here, you will have n equals to number of particles then over Avogadro constant. Okay, so second one I have here n equals to, so mass usually we will give a symbol small capital M, and molar mass we will give a big capital Mr. Okay, MR meaning will say that RMM, so if you happen to see AR, AR is called as RAM. So the third one we have N is equals to volume of gas, so we usually will write V gas over either 24 or 22.4. Okay, so important thing to take note, always remember this one must be in DMQ. Okay, so later on I will show you all a few questions, so I will use two techniques to actually solve out the question. So basically show you how I apply on this triangle to solve out on the question. Okay, so we will be moving on to the next one. Okay, so let's see for the first question. Okay, so this will be the one of the question. Okay, so whenever you read through the question, you might need to write out what are the information given first. Okay, so in this example here, you can see that you have 3 balloons. Okay, so the 3 balloons itself, it will show you that you have the mass. So once you see gram, you will know that you're having a mass. Okay, so you're having a mass 4.8, 16.8, 12.8. Okay, and when you read through the question, there will be several information given. They're giving you the RAM. So if the question giving you in RAM, then you might be able to calculate what is the RMM. Okay, so let's see for X2. So if I'm going to calculate what is the RMM for X2, so I will be able to get a value of 2. Okay, so the RMM for Y2, I will be able to get a value of 28. And then for the third one, the RMM for Z2, I will be able to getting a value of 32. Okay, so once I have all the RMM, I have the mass. Okay, so now I can use the method number 1 to solve it out for this question. So what I will do is that I will write it out. What will be the given mass? So I have X2, Y2, and I have Z2. So I will write it down, the mass that is given, 4.8, and then 16.8, and then 12.8. Okay, so I also calculate the RMM already. So now I can convert to mole, okay, where I will get 4.8 divided by 2. So this is how I get it as 2.4. Then 16.8 divided by 28. So this is how I get 0.6. And lastly, Z2, I will get a value of 0.4. Okay, so once you get the mole, so you can apply on the volume of gas formula, okay, where we have V gas is equals to, you get the mole, 2.4 times 24. So you should be getting a value of 57.6. Then Y2, you will get 14.4. And lastly, you will get 9.6. Okay, so from here, we're able to know that we need to arrange, okay, arrange the gas in ascending order, okay, or mengikut telip menaik. So we need to arrange that in an increasing order. So in this scenario, I will arrange as Z2 followed by Y2 and X2. Okay, so from here, I will be able to know the answer will be on donkey. Okay, so for this method itself, we are using a method formula. Okay, so basically there will be another shortcut that you can do for this question. Okay, so if you notice, the similarity in these two triangles is mole. Okay, so since you're able to get the mole, basically, if you want to skip the step that calculate of volume of gas, basically you can get the hint also from the number of mole itself already. So the smallest mole, when you times with 24 as a constant volume, okay, So definitely it will be still as a lowest volume of gas. Okay, so some of the students, if you want to have quick solve it out for this question, once you determine the number of mole already, you may able to actually arrange them from smallest number of mole to the largest number of mole, then you will be also able to get the answer of donkey. Okay, so this will be on method number 1. Okay, so if you are not a very good in memorizing formula, then my suggestion is that we can proceed to method number 2. Okay, so what we're going to do in method number 2 is that you will just need to remember the triangle. Okay, so what you're going to do is that you are going to write whichever information that you have into the triangle itself. Okay, so for example, x2. Okay, so x2, the information I have here is mass. So I write 4.8 gram here. Okay, molar mass I have already. Just now I already calculated. So molar mass here, it will be equivalent to 2. Then I want to determine what is my volume of gas. So in this triangle itself, anything up and down where you need to divide. Okay, so if you get 4.8 divided by 2, so this is how you get your n equals to 2.4. So once you get the value 2.4, then you just plug it in into here, 2.4. So anything side by side, you will just need to times. So this is how you get the volume of gas. Okay, so once you have done for x2, then you can proceed to y2, and then also you may proceed to z2. Okay, yeah. So far, can you all follow on this? If if you all can follow, then you may just let me know yes, okay, or okay, okay, good. Okay, so if you all, no further question on this question number 1, then I will be moving on to the next topic. Okay, so please feel free to ask any question. Okay, so we will try to collect it and then we will discuss after this session. Okay, so if you all know question, then we will be moving on. Okay, so most of the time, the mole question itself, okay, it will be combined with this stoichiometric. Okay, if you still recall, when we having the mole, when you learn about mole to mass, mole to volume, mole to particle, so most of the time we will apply into a chemical equation. Okay, where most of the time you need to balance the equation first, then only you can proceed to calculate. Okay, so from here I will give you an example. Okay, let's say we're having this chemical equation. Okay, so in this chemical equation here, whenever anything chemical equation given, you have to make sure one important thing first, whether this equation is balanced or not balanced. Okay, if this is a not balanced equation, what you're going to do is that to balance the equation. So here you have 2 nitrogen. So the product side also you have 2 nitrogen, so the nitrogen is balanced. But my hydrogen is not balanced because 2 times 3, total you should have 6H. Okay, so what can I do is that I can put a 3 here. So this 3 is what we call as the coefficient. Okay, coefficient to balance the equation. Okay, so once we balance the equation, we can get from this equation is that 1 mole of nitrogen can react with 3 mole of hydrogen in order to produce 2 mole of NH3. Okay, so this is based on the equation itself. Okay, but normally in the question, it won't be giving you exactly 1 mole or 3 mole. So if let's say I give you here, I'm having 0.5 mole. Okay, I only have 0.5 mole of nitrogen. So how many mole of NH3 that I will produce? So what we're going to do is that we check back on the equation. If 1 mole you can get 2, so 0.5, So the value here, you will get 2 over 2. So you were able to produce only 1 mole of NH3. So this comparison is what we usually call as a mole to mole comparison, where we call as a mole ratio. Okay, so I will show you another question on how we're going to apply on this mole concept with the mole ratio, okay, in order to solve it out. Okay, so this is the question that you normally see. Okay, so first thing, we will need to finalize out what are the information given. Okay, so from here it's telling you that oxygen mass will contain of this thing that we call as a potassium oxide. Potassium oxide formula is K2O. So when you react with water, so you will have this equation. So the equation is given. Okay, so we need to calculate out what will be the volume of oxygen gas. So we want to find out what is my oxygen gas volume, okay, at room condition. So we want to know is RTP condition. So it's RTP condition can be produced from 47 gram of potassium oxide. So we have 47 gram here. Okay, that's it, the information given. Okay, so how should we start with this question? Okay, so I will show you on 2 methods. Okay, so the very first method that I will show you is we will doing on the mole comparison. Okay, so whenever you have a chemical equation, so you check whether this equation is balanced or not. So this equation is already balanced. Okay, so the information given 47 gram, and then I want to find out oxygen. So since this is the 2 information given, so we only focus in these 2 information only. Okay, so in method number 1, okay, so what we're going to do is that we need to do is that from the equation. Okay, so we see only the equation itself. So from the equation, I know that 4 moles of K2O will going to produce 3 mole of oxygen O2. Okay, so this is from the equation. But the information given here is 47 gram of K2O. Okay, so you will know gram is not equivalent to mole. So in order to make gram become mole, we need to divide mass with molar mass. Okay, so from here we will have 39 times 2 plus 16. Okay, we need to divide 47 with the RFM first. So from here, we will get 47 over 94. So you will know that here will be 0.5 mole of K2O. Okay, once you get the mole already, then now we can calculate what will be the mole for O2. Okay, so some of your school, they may do it in this way. Okay, if you're not doing in this way, you can write in the way that mole of K2O over mole of O2. From the equation itself, K2O is 4 and then O2 is 3. So this is another way you can rewrite it. Okay, so I have my mole for K2O, so I just substitute 0.5. So I don't know my mole of oxygen, so I put it as an X. So 4 over 3. So from here, I may calculate out my X value will be equivalent as 0.375 mole. Okay, so once I get the mole, then I can apply into the volume of gas where I get the 0.375 I times with 24. So I should be able to get a value 9 dm cube as my answer. Okay, so these are one of the way that you can use it. Okay, where in most of the book, usually they will discussed in this method. Okay, so now I'm going to introduce you to second method where I usually will be using on the triangle. Okay, so by using the triangle, so first you have to know that what are the information given. So K2O is given in mass, so I need to use a mass triangle. So here I will write, I have 4 mole of K2O. Okay, so I will just write in what are the information that I have. Okay, so mass I have 47 gram, so I plug it in. Molar mass I have 94. So now you can see I have 47 and 94 up and down where I can divide them. So I will be able to get my mole here as 0.5 mole already. Okay, so for my oxygen, okay, we're using another triangle. So here I have 3 mole of oxygen. So I write 3O2. Okay, so I want to find out what will be my volume of gas. So the 0.5 mole here, I need to substitute into the N value here. Okay, so before I substitute into this N value, I have to consider the ratio 4 and the ratio 3. So how I'm going to do from here is that I will just need to get 0.5 times whichever the ratio for oxygen, so 3 over 4. So from here, I will be able to get 0.375. Okay, so once I put it in 0.375, anything side by side, we just need to times it. So when you times it, you will be able to get your volume of gas will be equivalent to also 9 dm cube as your answer. Okay, so far can you all follow? Do you all have any question? If you have no question, then we will be moving on. Okay, if you have, then please feel free to post it out your question in this chat room here. Okay, so if no, then we will moving on to the next question. Okay, so it will be on question number 3. Okay, so for question 3, okay, so question 3 is also something quite similar to your question number 2. Okay, where again, in this question here, there will be few information given. So we need to find out what will be the mass for this lead to nitrate. Okay, and now the information given here is that I having 3.6 dm cube for oxygen. Okay, so if you recall how I apply on method number 1, okay, so what I going to do is that I will going to do where I going to put it in the number of mole for lead to nitrate over oxygen. So from the equation, I get a ratio 2 over 1. Okay, so I want to find out what will be the mole for my lead nitrate. So oxygen, I have 3.6. Okay, so what I will be going to do is that I need to convert my mole, I mean the volume of oxygen to mole. So here I will get 3.6 over 24. Okay, so from here I will get the mole for lead to nitrate. So I will be able to get a value of 0.3 mole. So once I get the mole, so I can calculate the mass by getting 0.3 times 50 RFM for lead to nitrate. Okay, so lead to nitrate is having an RMM, so you will be getting 207 plus with 2 times of 14 plus 48. So you should be getting a value 331. Okay, so from here, when you calculate out, you will be getting 99.3 gram. So the answer will be B. Okay, so this will be on method number 1. Okay, so if you are not familiar in method number 1, then we can use on method number 2. So again, method number 2, the information given, so you just put it in the value. Okay. Okay. So I have my mass of oxygen. So what you're going to do is that right on top here, 1O2. So here I have 2 Pb and O3 2. Okay. So for oxygen itself, you have those information already, so you can divide them off. So from here, you will be able to get 0.15 mole. Okay. So you can plug in this 0.15 here. Okay, but you need to consider the ratio. So whichever value you plug in here, you need to times the coefficient here first. So you times 2 over 1. Okay, so from here you will get 0.3 mole. So once you get the mole, then you can get 0.3 times with the molar mass, 331. So this is how you get also 99.3 gram. Okay, so I have introduced you on these two methods. Okay, so you can see which method you are more comfortable. But anyhow, method number 2 is where you may need to remember as a picture of this triangle. Okay, so if you are not a formula person, then you may remember on this triangle. So hope that it will be help you to solve it out for this mole concept. Okay, so we have done for this mole concept topic. Okay, so if you have any question that you want to ask about this mole concept topic, you may post your question in the chat room. Okay, so the next one we will be moving on. We will be moving on into this topic we call as chemical formula. Okay, so again will be a calculation topic. So in chemical formula here, basically we will discuss on two important topics where we call as empirical formula, and another one we call as a molecular formula. So how do we differentiate molecular formula and empirical formula? So empirical formula normally is a formula that you can further simplify. Okay, so if you can see from here, Na2O, you can further divide by 2. So if they can be further simplified, so this one we call as molecular formula. And the simplified version we call as empirical formula. So one keyword you need to remember for molecular formula, usually we will remember on keyword actual. Okay, where it will show you that the actual number that is present, where empirical formula will be a simplest version that you couldn't be divided anymore. Okay, so I give you another example. So if I have H1O1, so both of them is 1, so this is considered as empirical. Okay, so if I times 2, then I will be able to draw it out as a hydrogen peroxide. So now hydrogen peroxide is what we call as molecular formula. Okay, so moving on. So I have this compound molecular formula. So if I simplify it, I will get this empirical formula. Okay, so if you see from here, the empirical formula and molecular formula for fructose is the same. Okay, so there will be this possibility that you will be getting the same molecular formula and also empirical formula also. Okay, so the next one we will be going to see what are the steps that we can remember when we're going to calculate on this molecular formula part. So I will discuss on the molecular formula calculation first, then only I will discuss the empirical. So normally the question will be given in such a way. So it will be given like in percentage, okay, or sometimes it will be given in gram, okay. So when you read through the question, you have to check one important thing. Okay, if RMM is given, meaning to say that you have to calculate molecular formula. If RMM is not given, then you are not calculate molecular, but you are calculate empirical formula. Okay, So what I'm going to do is that normally I will summarize in a table form. Okay, so the step that we're going to go through. Okay, so the very first step, we determine what will be the atom that is present. So from the question itself, you have carbon and then you have H. So you have C and then we have H. Okay, so this is the very first step. So normally I will call this step as A step. Okay, then following then, what are the mass that is given? Regardless they given in gram or percentage. So you just write it down. So here I have 85.71, 14.29. Okay, where I usually will call this as a M. Okay, then we have the following step, okay, where we need to convert them to mole, also a N step. So here we have to consider on RAM. So in this mole step, I need to get 85.71 over 12. I will be able to get a value 7.14. So here 14.29 over 1, so I will get 14.29. Okay, so in order to determine the mole ratio, so the important part here is that you have to determine between this 7.14 and 14.29, which one is smaller value. So I will be able to know 7.14 is smallest. So in order to determine the mole ratio, so make sure you find the smallest mole. Okay, so from here, 7.14 over 7.14, I will get a 1. So in this example here, I will be getting a value of 2. Okay, so the mole ratio must be an integer. Okay, so from here we can summarize the empirical formula as C1H2, where we normally will only write CH2. Okay, so if the question asking you to determine only empirical formula, then you will just stop as this part. Okay, but now we need to proceed to calculate what will be the molecular formula. Then we need to proceed on the next step. Okay, where we need to calculate out the empirical formula mass. So from here, empirical formula mass is the same thing like you calculate your RMM or your RFM. Okay, so I have 1 carbon, so will be 12 plus hydrogen will be 1 times 2, so I get 2. So I get 14. Okay, so once you determine the empirical formula mass, so we need to determine the factor. So the factor will be getting the molar mass or the RMM divide with your empirical formula mass. So you can see that RMM is given as 56. So I will get 56 over 14. So I will get a value of 4. Again, must be an integer. So from here, I can determine my molecular formula where I get CH2, the whole thing, I times with 4. So I will be able to get as C4H8. Okay, so normally calculation of empirical formula, molecular formula is a popular topic in paper 2. Okay, where it will ask you to calculate what will be your molecular formula. So based on this molecular formula, we can link to other chapter in Form 5. Okay, so if you have any question on this molecular topic, you may also post your question into the chat room. Okay, so we will see another question on calculation on this. Okay, but now we will be doing on a more simplest one. We're doing on an empirical formula. Okay, so in this question itself, it tell you that you have 1.52 of metal oxide. Okay, so anything on oxide, you know that must be consist of O. Okay, so it say that this compound is reduced. So if you don't, if you still haven't come across on this term on reduce, okay, it's still okay. Okay, because this reduction you will be going to learn in your Form 5 chapter 3. Okay, so you have this 1.04 gram of metal is obtained. Determine the empirical formula. So again, I will do it in a table. So the step that I will be going to follow will be the same. Start with A, atom. Okay. So from here, we know that we have metal oxide. So you can see from the hint in the, the answer here, you have M and O. So definitely will be M and O. Okay. So it tells you that the mass of metal is 1.04. So you put it here, 1.04. So in order to determine the oxygen mass, so you need to get 1.52 minus 1.04. So you will get 0.48 gram. Okay, so this question, it may need you to do some calculation to calculate out the mass. So once you get the atom part, then you already get the mass part, then the following part, you can calculate out the mole. Okay, so from here, I will get 1.04 over 52. So I will be getting 0.02. So 0.48 over 16, I will get 0.03. So between these two columns, so again, this is smallest mole. So I will get here, divide itself. So here you will get 1. So this one you divide by 0.02, so you will get 1.5. Okay, so important thing, 1.5, okay, 1.5, if you round off to 2, so totally wrong in empirical formula. Okay, anything when you see a 5 behind, what you can do is that you can times 2 to make it as an integer. Okay, so if you times this column as 2, make sure also here also you times a 2. Okay, so that's why here I will be able to get my empirical formula here as 2, here as 3. So the final empirical formula will be M2O3. So the answer here will be as C. Okay, so C will be your answer. Okay, so how do you remember on this step? Okay, so this step itself, normally I will be, put it in these terms where I call it as AM, MME. Okay, so how do I remember this is that AM is morning. Okay, morning time, I need to minum Milo. Okay, in order to keep me energetics. So this is how I get the empirical formula. Okay, so sometimes you might need to know what will be the step. So hopefully this short term will be able to help you to remember on this step. Morning time, we need to minimum Milo to keep us energetic. So that's why we can get empirical formula. Okay, okay, so I have another last question to share with you all on this topic here. Okay, so for this topic here is where they given you the empirical formula, but now we need to determine what will be the mass. Okay, so again, we use back the same step. And then now you can see that empirical formula are given. Okay, so I want to determine what will be the mass for antimony. Okay, the mass of oxygen is given 0.48. So once you have this, you may still proceed to the mole. So the mole for this will be X over 1 to 2. So this one, 0.48 over 16. So you will get 0.025. Okay, so in order to determine the mole ratio, so what we're going to do is that we were going to get the mole for antimony over the mole for oxygen. So from the empirical formula, you know it's 2 over 3. So 2 over 3. Okay, so from here, the mole for antimony is X over 122 over mole for oxygen I have here 0.025. So by solving out this part here, okay, I will be able to get my X is equivalent to 2.44 gram. Okay, so from here, I will be able to get the answer as B. Okay, so this will be the several ways that you can actually solve it out okay, and then this is, the value of X as 2.44 gram. Okay, so if you have any question on this, you may post in the chat room. So later on, once we finish, we will go through on the question that you might have. Okay, so as a summary for these two topics that I have discussed for today webcam, okay, webinar. So basically, this is a summary that I might need you all to remember. So in the mole calculation, you have to remember on this diagram. And in the empirical formula part, okay, we have to remember on this step, okay, where I just simplify as AM, minimum Milo, energetics, okay. So if you happen to come across on molecular formula, then you might need to, carry out on these two steps, okay. So the pink box here is going to show you that the important thing that you might need to calculate off in order to proceed to the next step, okay. So that's it for today webinar, okay. So hope that you get a clearer picture on this small concept and empirical formula section, okay. So thank you everyone for joining us. So I will need to pass the mic back to Anis. Yeah. Okay. So yeah. Okay.
Okay, sorry, Miss Grace.
Yeah.
Okay, you can continue for Q&A session.
Okay.
Because
Okay.
just now my mic tak boleh turn on.
Oh, okay, okay.
Okay, okay.
So I will answer those questions that I already posed in the group chat room lah. Okay, I can see that there is a one question here from GW. Okay, it's actually asking me, okay, what does the AR in the pink box stand? Okay, so the AR is what we call as a RAM. Okay, so from here, okay, so this is the AR. So AR is what we call as a RAM. So important thing you always have to remember, in order to convert mass to mole, you have to divide with your RAM. Okay, unless you are having a part here, for example, I give you H2O, then you need to divide by RMM. Okay, but in your syllabus itself, I don't think we will be having the molecule in this section yet first lah. So when you're having mass convert to mole, you need to divide with AR, where we call as RAM. Yeah. Okay, so have I answered your question from GW? Yeah. So there will be second question. Okay. This second question is from this student, Lo Qi Xuan. Okay. So the question is asking, how if the mole ratio is 1 and 1 to, 1 and 1.25? Is it need to times 4? Okay, the answer is yes. Okay. So if let's say, okay, so I give you another example. So if I get my mole ratio, okay, is 1 to 1.25. So here I couldn't times with 2, because if I times 2 also, I won't be able to get an integer. So the most possible thing is that I need to times 4 times 4. So I will get 4 to 5 as the ratio. Okay, so just that important things that you need to take note is that 1.25 cannot round off to 1 also. So this is a very common mistake that student usually will have. Okay. And then, okay, I have another question here. It's asking, okay, morning. So the equation given in the question has already balanced, or we need to observe ourselves whether it's balanced or not. Okay, so for this 接问, okay, so it will be always make it as a good practice to balance the equation first. Okay, so most of the time I would say if the question given in SPM objective, normally the equation is already balanced equation. Unless in paper 2, then normally you might need to balance on your own, then only you may proceed. Okay, so just to make it as a practice first, whenever you have any chemical equation, check whether they are balanced or not. Okay, you may pick 1 to 2 elements to check whether balanced or not first, then only you proceed to the mole. So if you didn't check for this step, then definitely the mole that you calculate up will be wrong already. Okay, yeah. So thanks for Jaewon question. Okay, so any more question that you all have for this for today online, I mean this webinar, then you may still post it into the chat room. Okay, so I'm hoping that the techniques that I introduced to you all, especially on the triangle method, will be useful to, those that is not good in formula memorization. Okay, because sometimes when you use on the formula memorization, you might not able to see the relationship. So if you just remember on the triangle, you plug in the information into the triangle, then you can see the link, then that is how it will be able to help you to proceed. Yeah.
Hello, teacher.
Yes.
I
Yeah.
have a question.
Yeah.
Usually, what's the common mistake that students will do regarding this in SPM, mostly?
Uh, which topic that you are mentioning on, mole or empirical? Yeah.
Empirical.
Empirical. Okay, I will say the common mistake that student usually will make in this section, I will say will be this one, RAM. Okay, what I usually got from this section is that student usually will get wrong RAM, especially they will get the proton number to divide. Okay, so one thing I would like to stress on here is that, so when you see on the periodic table, so again that I mentioned just now, so you may see the 2 numbers. So instead of getting the RAM to divide, most of the students, they have a common mistake, they will get the proton number to divide. Yeah, so because of this reason, then the following, a step that you're going to have will be totally wrong. That's why here it's important that you have to remember, get your RAM. So how do you remember which number is your RAM? So always remember the bigger number will be RAM. Or you can remember in this way is that whichever numbers that you see smallest, they are continuous. Normally they are proton number. Okay, or another way that you can do is that you may check your periodic table. Okay, normally the periodic table, they will have a section, they will tell you which number is RAM and which number is your a proton number, or we call as a atomic mass. Yeah, so make sure you get the correct atomic mass. So this is the first common mistake. Second common mistake is something that I mentioned just now. When you have 1.5, if you round off to 2, so this one is totally wrong. So 1.5 you need to times 2, and also 1.25 you need to times 4. So these are the 2 common mistakes, yeah, for the topic of empirical formula. Yeah, so have I answered your question?
Yeah, thank you, teacher.
Thank you. Yeah. Okay, so here I have another question from this student, Wenxuan Fu. Okay, so the student is asking, should we round off if the mole ratio is 1 and 1.9? Okay, yes. So if you happen to have the value in your mole ratio, okay, So anything with, for example, 1.9, 2.1, you may round off to 2. So anything with 1 and 9, yes, you may round off. But anything ending with 5, okay, 0.5, you cannot do round off. Okay, so if I getting a value 1.9 or 2.1, I may round off to 2. Yeah. Okay. So and any more question?
Okay. Any more questions, students, before we end? One last question, if you have. Okay, I think macam tak ada je.
Okay.
Okay.
Okay. Yeah.
Okay, student, if tak ada, okay lah, now is 11:06. Okay, if tak ada, okay, I think that's it from Miss
Yeah.
Grace.
Okay.
Okay, thank you, Miss Grace. And so, so just now we just finished our Q&A session. Again, thank you, Miss Grace, for the fruitful and informational Oh, sorry, I muted my voice. Okay, sorry. Okay, everyone, thank you again, Miss Grace, for the sharing session. I'm sure all students could have learned something today. So any one of you, I hope apa yang you tak clear, you can clear off for today's topic. Okay, so before we end, I would like to ask you to fill in the form for e-cert. Jangan lupa isi, kalau tak isi, tak ada e-cert. Okay, kita akan buka this link for 30 minutes, then after that we will close it. Alright, you boleh isi sekarang. You copy this link, then isi saja. Then after that we will give you the e-cert. Kalau after this you miss the e-cert, nanti tak ada e-cert lah. Alright. Okay. Okay, you can end. And then lastly, I would like to thank you again for Miss Grace and everyone and every student yang participate for this activity. So next, we will have for this afternoon, we will have a SPM English. So a little bit trick and treat in essay writing. So if any one of you yang join for afternoon session, make sure you log in lah. Jangan daftar tapi tak log in, rugi saja. Alright, so make sure 2 PM, so by 1:45 you stand by. Okay, and of course, lastly, for Friday, we have for effective time management, 10 AM, and then in the evening, we have brain food, what to eat when revising at 2 PM. Okay, and lastly, remember, you can join our Telegram group, Segi PG Outreach. Kita akan blast all our information about Segi College or any activities or webinar that we will conduct in future, we will blast in this. So maybe like next week, we still have, I think we still have few slots that we are still haven't yet blast, so we blast soon in the outreach, in the group. So make sure you join, then you can get the latest news. Okay, then maybe any webinar yang you interested to join, you boleh join. Okay, okay, that's all for today. Thank you so much for coming in. So I hope to see you again, and remember, stay at home and stay safe. Bye-bye.